Yeah, event-driven microservices, sense, nonsense, and a way forward. That sounds pretty daunting, and it is. It's a 30-minute presentation, so there's a lot that we won't cover. Fortunately, there's a Q&A session after this, so feel free to dive deeper into any of those topics. So before I became CTO of Trifork, of Axonic, I was CTO of Trifork, and in that consultancy role, or in the consultancy company, I visited a lot of projects that were in trouble. So I used to joke that if you would see my face, it was bad news. And I've learned a lot from those mistakes of others, and in my attempt to do it slightly better than that, I created Axon Framework, later Axon Server, and the company Axonic. So let's go a little bit back in time. So this might be a couple of years, it might be a couple of decades, it might be yesterday, it might have been 10 minutes ago, but the dominant architectural style that I still see nowadays is what you would call the layered architecture. Basically, and I love this image from Ted Neward, who calls it the box cylinder architecture. And the cylinder holds the data, and you don't want people accessing the data directly, so you put a box in front of it. But then just having one box in front of it is not enough, because that box will then contain business logic as well as UI specific logic. So we put the business logic in the middle box, and then we put a box in front of it for the UI logic, if you will. And this architectural style emerged in the 70s. At least that's what my research told me. And it was designed to solve some of the problems that we had in the 70s. I seriously doubt whether the problems that we're facing today are the same that we had in the 70s. So that's I mean, half a century ago, right? So the problems that we're trying to solve nowadays, when we apply this architectural style to it, very often such a monolithic application evolves into what one would call a big ball of mud. But as you can see on the picture, the big ball of mud is not really mud, right? And on this particular instance, there's still the architect sitting on top of it, proudly presenting its creation. It's really proud, and it's defending whatever it has built here. Probably not even realizing the kind of mess that he's sitting on. And the problem with a big ball of mud is that the only real way to change the system is by adding more mud to it. The internal structure is lost to a degree that we don't have the confidence anymore to change the internal structure, right? It's too far gone. And this is something that may feel familiar if you're on certain projects. And very often what we do is we do a complete rebuild. And that's where microservices come to the rescue, right? So slightly later than the 70s, about 6 years ago, microservices really became a hot topic, a very popular way of deploying and building applications. So you could say what has emerged is a universal microservices architecture, although there are so many different styles. But in some of them, what I noticed was still that same box cylinder principle, but now in a distributed fashion. So you would actually still have that feel of, well, there's entity services. There are services that focus on the data storage, right? So there's a customer service, and when you need to modify a customer's state, you go to that service. Then there's business logic services, and we want them to be separate from the rest, because we can then reuse those in the BFF services, the backend for front-end services, for which we expose certain APIs that are more channel specific. So there's still that box cylinder principle in there, but we've just increased the number of deployment units that we have in our application. So basically what we did is we took the principles that gave us a big ball of mud, sooner or later. In well-architected applications, it can take, fortunately, it can take a long time. Sometimes I've seen the big ball of mud emerge before the project ever reached production. And then we increase the number of deployment units. Well, it's pretty obvious what you get. You get a big pile of mud. The problem is we should not be focusing on increasing the deployment units. For too long, we've assumed that we can reach modularity by building more modules, but it doesn't work like that. You just get a distributed big ball of mud instead. We should focus first on increasing the modularity of an application or of a system, preferably a monolith. And I agree, in PowerPoint, that's fairly easy. You just use a few squares with happy colors, and then you're done. Of course, in actual software engineering, there's much more to it. But we should strive for that modularity, and I'll give a few hints on how you can achieve that. And as soon as we have that, then we can start thinking about extracting components and increasing the number of deployment units that we want to have. And that sounds very easy. Unfortunately, it's a wild world out there, and there's a lot of anti-modularity forces, right? There's technical debt is for sure one of them, but there's also a lot of misunderstanding about the actual thing to build, right? We have to realize that sometimes when we start something, we just don't know everything up front, right? That's why we have agile practices, so we can learn. But in that learning, we have to be careful to not lose that modularity, and slowly we get drawn down to the bottom right. So we need a way to stay up there and make sure that our applications stay modular and don't go back into the big ball of mud structure. So a little bit later, parallel to that microservices movement, there was a big event-driven or hype, you could call it. And so events to the rescue, right? Whatever problem you have, you put in events or whatever popular event bus mechanism you want to use, and then all problems disappear like snow by the sun. So the whole idea of events is that, just imagine we've got two services, and these services need to somehow cooperate. Right? When service A receives a request, it needs service C to do something as well, or at least service C needs to do something as a result of what service A just did. Well, in a very naive approach, you could say, well, we just have service A call service C and say, hey, it's your turn to do this now, or do something. That's not that problematic. It gets more problematic as soon as services B and D emerge as well. And now by adding these two services, we need to modify one of the existing services, namely A, to also call B and D. Well, that's where it gets problematic already. And what if service A suddenly floods service C with requests that it can't handle anymore? We just heard a keynote by Jonas Bonner, and it's obvious we need to isolate these failures. And this is a really good way to get whatever excessive load service A gets and just dump it onto another service, and then, well, you'll have a cascading failure waiting to happen. And this is where the concept of events become very useful. So what we can do is, instead of service A calling these other services, we can just emit an event that, hey, this happened, and then all these other services can watch whatever topic or a queue that these events are published on, and can watch that, and when something happens, they will respond to it. And this is a very nice way to decouple the interaction between these services. But there's a few caveats, and we'll get to that. So we get the new architecture, which is our event-driven microservices architecture. And again, the only real thing that changed in many of those systems is that they're not really event-driven. They're just using events to communicate. But the responsibilities of these services are still exactly the same. And that doesn't solve our problem. Just putting in events as a way of communication will not solve the problems just like that. So basically the promise is that as soon as we use events, and if you read the Reactive Foundation Principles document, you'll see events mentioned a couple of times. And it's not because events are the solution. The events are a solution to some of those problems, but we have to be very careful when to use them. So it's not that by using events, we now have a cloud native and reactive system. Right? Events are an ingredient to that. There's also the promise of location transparency. And yes, by emitting an event, you don't care where the actual consumer is, right? They're decoupled in space and time. They can consume at their own pace whenever they're ready to consume the event from whatever queue it was put on. There's also this promise of evolutionary architecture. In our new design with events, we can very easily add new components. We can add behavior to the system without changing any of the existing components in the system. So we can change the behavior of the system as a whole by adding a single new component. And that is a very powerful mechanism, and that is very often used to make sure that a system is very evolvable, if you will. And the event streams that we produce, they are very reusable, right? Once an event is published, any consumer can pick it up. And as long as that event is available for these services to consume, we can reuse those events and derive interesting other facts from those events. At least that's the promise. The only problem is that the pictures you get in the books often show you the bright side of things, the happy path, right? The success stories. So you just see a picture of a beautiful jungle with this really nice waterfall in the middle, and well, especially in a year like this, you would really like to go there and just enjoy that tranquility that you see there. But unfortunately, in any environment, when you get closer and you get to see the details, you notice that not everything is happiness. Right? There's always the little details, the little mosquitoes in any type of architecture that you will only really face or notice when it's too late. Right? And that's also with an event-driven architecture. There's a lot of things about events that are powerful, but there's a lot of little mosquitoes around that are ready to start annoying you. So one of the problems is in many systems, events are sort of a side effect, right? Those systems aren't truly event-driven, but they do whatever they need to do. They store whatever information they need to store. And then as a side effect, they also publish events to whatever event publication mechanism that you would like to use. And the problem with that is, well, guaranteeing that whatever events you emit and whatever decisions you've made in your applications and the decisions you're going to make in the future, they might be consistent, or at least they become eventually inconsistent. So it's very hard to guarantee that every decision made, every change is actually published as an event. And on the other side, everything that you publish as an event is actually accounted for every time a new decision is made by that component. Right? Of course, you can use two-phase commit. You can store state and then publish an event and use two-phase commit. But we now know that that is an anti-availability pattern. So we definitely don't want to use that. And the other thing is that any afterthought, but especially one like this, only makes a system more complex. Right? Anything that the architecture did not account for is added to the complexity of whatever solution that you're building. And to some extent, that's not problematic. But if you do that too much, you'll just build up complexity and a lot of technical debt that is really difficult to pay back. Because the architectural debt, if you will, is the most difficult debt to pay back. Right? It's not a simple refactoring and then we're done. Like, oh yeah, we just need to make our system more events first in design. You can't do that after the fact anymore. So when we look at events and when we look at the information that very often gets stored in a system, there's something interesting going on. So we can say what happened in an application, and we can compare that to the information that we actually store in a specific component or in an entire system. Doesn't really matter that much. So just imagine we've created an order. Well, then we can see in the whatever database that we might be using that there's an order entry. And in this case, it has the identifier 123, and its status is awaiting confirmation. But it's an empty order at the moment. And then we add 2 chairs to the order. So our state storage changes. We now have this order, still the same identifier, same status, but we've added those 2 items. Now we decided to remove 1 item from the order. We just don't need 2 chairs, 1 is good enough. So we changed that, right? We changed the state again. And as we progress through that order, the checkout process, if you will, the ordering process, we update the state with whatever the current state is. Now, the problem with that is every time something happens, we overwrite the information that we know. And we lose everything that we had until that moment. But if you look at where the actual value is, where the interesting information is, it's on the left. But what our system stores is on the right, and then we produce the left as a side effect. But it's the most valuable thing, so why do we do that? Why don't we store the events instead? Because that's apparently the most valuable thing that we have. We need to guarantee that that's correct, and then we can derive the state on the right as a result of that. Right? So we don't store that anymore. And that's the concept of event sourcing. And I'm not going to pretend that event sourcing is a silver bullet, just use event sourcing and that's the only way to be event driven. That's absolutely not the case. But in some cases and in some components in a system, it might be very important to make sure that the event stream is basically telling you the truth, the whole truth, and nothing but the truth. And if you have an entire system relying on the correctness of an event stream, so you're producing events and you're using those downstream, you better make sure that the events you produce are guaranteed to be correct. And the more downstream you have, the more important that correctness of the event stream becomes. And doing that as a side effect is, well, I doubt you could call that event driven, right? It's just, the events will start driving your application or your system instead of events driving the system. And we don't know where those events are going to take you unless you take full control of them. Now, there's another issue with events, and they have an awkward type of coupling, right? There will always be coupling between 2 components that somehow need to interact, right? If one component needs to respond to another, there is coupling. There's nothing we can do about it. But events, they have something awkward about them. And the problem is they basically invert the dependency. So now it's the receiving component that watches the space of the producer to see if something happens. That's not a bad thing per se, but it also obfuscates the dependency a little bit. It becomes harder to find out which event impacts which parts of the system. So documentation becomes very important, or at least, well, if you have some form of live documentation, that's even better. But making sure you get those things right is very important. Otherwise, you have no idea what side effects you may have when you make a change to those events or decide to not emit the event in the exact same occurrence anymore, but in a slightly different situation. And another thing is communication cannot always be in past tense. Right? Events typically describe something that happened in the past. And if you communicate, well, you try that at home, right? Try communicating everything in past tense. Just only emit facts. So don't ask for something to drink or don't ask what's for dinner. Just say, I'm hungry. Because those are the only facts. Well, you'll get a very awkward situation at home and will probably not even take an hour, right? So we know that communication cannot only be done with events. And sometimes we see these presentations about, yeah, just use events everywhere. If you just use events for communication, all your problems disappear, and suddenly you are location transparent, decoupled in space and time, and etc. Well, fantastic, but you'll get a very awkward architecture as a result. And that's because events are one of the means of communication that you should think about. Events are a pub-sub mechanism, but there's other situations, there's other reasons why components want to communicate. And we've identified basically 3 reasons conceptually why a component would want to communicate with another. And commands are the case where one component wants to tell another component that it needs to do something. And the amount of pointing fingers at components varies depending on the type of tools that you use. Preferably, it's just saying, hey, I want this done. Hey, system, make sure this gets done, because I think right now this is, some component should be doing this. And you expect some acknowledgement back, right, typically. But it gets routed to a single destination, which gives you a bit of acknowledgement. Events are pub-sub. You just emit a fact. Here's a fact. You give that to your system, and components will handle it the way they need to handle it. And there's no acknowledgement, no feedback whatsoever. And then there's queries. Sometimes a component just has a need for information that it does not hold itself. It does not keep track of the current state of that piece of information. So you can ask the system, hey, give me that information. And one way is what we call a point-to-point query, just a single destination, and you get the single authoritative answer. But in some cases, you will want to know different opinions of components. Like typically in complex retail systems, you have different pricing strategies. So you can ask, what is the price of a particular product under a specific situation? And it can give you different prices depending on your profile, your whatsoever. Right? In that case, you have a scatter-gather query. You scatter your question to different components, you gather the responses, and then reduce that to a response that you can work with. And we need to realize that an event and a message are different things. Right? An event is a message, but a message is not always an event. And when you really use those messages in the right place, that's where you get the true location transparency. If you implement them the right way as well, and we like to implement them as explicit messages, because it's so much easier to distribute explicit messages rather than a method invocation. If you want to include remoting to a method invocation, well, there's plenty of examples of projects that have turned into, gotten into trouble because of that. So explicit messaging is really, really important. In that case, once you have reached that location transparency, you can start extracting components. You can evolve towards microservices much more fluently. So instead of going from whatever idea that you have in mind and trying to design a complete microservices environment and just every noun that you can find becomes a service, well, if you go that way, it's a very tricky, it's a dangerous path, and many projects have died on that path. Or if you're lucky, you'll just turn into a distributed big ball of mud and maybe make it to production somehow. Instead, try starting with a monolith where you build the location transparency, but having everything in a modular monolith gives you much more flexibility on how to change the internal structures. If you find out you've got the component boundaries just a little bit wrong, it's so much easier to get it right if everything is in a bigger deployable unit than when it is deployed already in very small components all separate. And as you learn of those non-functionals and learn about which ones are more important than others, you can then identify the components that need to be deployed separately. Because a component should not be separated for functional reasons. It's always non-functionals. And then as time evolves, you can do more and more. And of course, that's very easy to say in a presentation, but there's a lot of technical complexity involved with doing this kind of thing, right? Especially distributed systems, where rule number 1 of distributed systems is don't, right? So why do we even consider doing microservices. Well, there's a rule number 2, 3, and 4 as well, just in case you cannot stick to don't. Of course, one problem with distributed systems is delivery guarantees. How do you guarantee a message gets delivered? How do you guarantee it gets delivered at least once or at most once, right? Those are your options. How do you choose them? How do you guarantee that? How do you guarantee that a message gets delivered in a timely fashion, right? That there's no excessive delays and etc. What about when something goes wrong? How do you recognize those cases? What do you do in those cases? What if the message structure needs to change? Right? How do you deal with that? If you use event sourcing and you want to store your events, then you have to think about, how do I deal with my increasing storage size? How do I handle that? How does it keep performing, etc.? And then how can I trigger a replay? And there's a lot of tools out there these days that can help you, right? These event-driven native tools out there, they've been around for quite a while, and a lot of them have matured. Obviously, we have some of our own, but the ecosystem is getting a lot richer these days. So definitely you want to have a look at those tools to see how they can help you. But even more important than tools is discipline. We really need to learn to have discipline in how we apply those tools. And this is a picture from the Karate Kid, where the young boy wants to learn karate. And the first thing he has to do is wax Mr. Miyagi's car. Wax on, wax off, right? And he's like, but how does this help me be better at karate? Well, we have to get that muscle memory in our field of engineering as well. The muscle memory to use the events the right way, if we want to go for an event-driven system, and get back to the basics and get those right, and then move forward. And those basics are evolving as well, right? There's different techniques that we can apply other than waxing cars, fortunately, that help us design event-driven systems such as event storming and event modeling. So in closing, beware of coupling. Realize that events are a means of communication that comes with its own shape and form of coupling. Consider commands and queries as well as those events. And that microservices are a journey. Right? They're not a destination, they're a journey that starts with a monolith first. But most importantly, have that discipline to wax on, wax off. And when you use the right techniques and the right, have the discipline, then the tools that you should be using will emerge automatically. And I'm pretty sure that is not a coincidence. So I guess time's up. So thanks a lot. Here's some information for your reference. And if you have any questions,